Okay, class, so this is the last section in 1.7, and that we solve an absolute value inequalities. There are two rules to take note of here. One, it says the solution of the absolute value is less than c are numbers that satisfy negative c less than u less than c. And it also states that the solution of absolute value of u greater than c are numbers that satisfy u less than negative c or u greater than c. So keeping that in mind, let's look at a problem we can actually apply these things. And the same thing applies for if it's less than here, this applies for less than or equal to. It's greater than here, this also applies for greater than or equal to. Okay, so with that in mind, let's try this problem here. Negative 16 greater than minus 2, absolute value of 4x minus 5. First thing we want to do is let's divide by 2 in order to get this over here all by itself. So we would say a minus 2 here and a minus 2 here. One thing to take note of when dealing with absolute values is that if you're dividing by a negative number, that changes the sign right here to the opposite of greater than, which is less than. So this will be 8 less than 4x minus 5. Because these twos cancel each other out. So 8 less than 4x minus 5. Remember, if it says an absolute value of less than c, how we set that up? Okay, let's switch this around so it can be just like this. So if we switch this around, then we have 4x minus 5, absolute value 8. Now, it's the solution of the absolute value greater than c. See, that's why I like to switch it around, because this right here is pointing at 8, but it makes it look like it's less than. But if we turn it around this way, then it's set up is greater than, and this is the correct way. And look at this here, absolute value greater than c, absolute value greater than c. So now we see that we would set it up like this right here, right? Okay, I hope you was able to keep up with that there, because that's very important when dealing with absolute values, and sometimes a lot of people get those things mixed up. So with that there, we would take this and say 4x minus 5 is greater than 8. 4x minus 5 is greater than 8. 4x minus 5 is greater than a negative 8. So now we have it set up like this. Sorry, we have this u is greater than 8. Satisfy that right there. Then we have it as less than a negative 8. So now we add 5 here, add 5 there. 4x is greater than 13. Now we have this here, add 5 here, add 5 there. 4x is less than what? A minus 3. So this right here is x is equal, well, x is greater than 13 over 4. X is less than a minus 3, 4. Then we come here and we say, how do we graph these things? All right, so let's draw a line. 0 here. We have a negative 3 over 4. 1, we know that's like 0.75. So that's somewhere up in here, right? So we do this right here. We know this is a parenthesis because it's just less than. Heading out this way. Then we have 13 over 4. 4 going to 13. Let me see. 4 go into 3. 12 times, right? 4 into 13 is 12. So it's somewhere 1, 2, 3, somewhere between the 3 and the 4. The next one is right here, heading out this way. That's how we would graph it. Now, if we had to put it in notation, we would start on this side here. Coming in from this side, we know this will be a negative infinity, comma, negative 3 over 4, union sign. Next thing we hit is 13 over 4, comma, a positive infinity, because this goes on forever. And infinity means it goes on forever. So that will be the solution to this problem right here. Negative infinity, negative 3 over 4, and then 13 over 4, positive infinity. Okay? All righty. Now, let's do another one. I'm going to erase this here. Let's say a negative 2. Negative 2. Absolute value 3x plus 5 plus 7 greater than or equal to negative 13. Let's subtract 7 on both sides. So now we have negative 2, 3x plus 5 greater than or equal to negative 20. Divide by a minus 2 on both sides. If you divide by a minus, divide by a negative sign, it changes the sign there, right? All right, so this is going to be 3x plus 5, absolute value sign, coming back this way of 10. So now what we have it set up the way this first one. Absolute value less than or equal to is less than or equal to in this side, C. So we have it set up like this. So now we know that we set it up that way. So we say negative 10 less than or equal to 3x plus 5 less than or equal to 10. Subtract 5 all over. This will be a negative 15 less than or equal to 3x less than or equal to 5. Divide everything by 3. Now, look at what we have. Dividing everything by 3, now we have minus 5 less than or equal to x less than or equal to 5 over 3. So let's graph it. We draw a graph. 0, just put a minus 5 here. 5 over 3, that's somewhere, this is a 1. And let me see, negative 5 is here. We know this is a bracket. This right here is somewhere up in here, I'm thinking. You know, this is also a bracket. And we draw it just like that, right? All right, so now that we have that, how will we write this when it comes to our solution set? Well, our solution set would be negative 5, comma, 5 over 3 with brackets on it. That will be our solution set, how we would write it as our solution set there. All right, but this 3 over 5, I think 3 over 5 is 1 point something. So this would actually be over here a tad bit instead of before the one. It'll be after the one. Be over there a tad bit. So that's how we would actually solve that problem there. And that's solving an absolute value inequality. I would say the key would be these two things right here. This would be the key to remember when solving these. Because once you get it broken down into this phase here, all you're doing, you're looking up here and you're saying, okay, this is less than or equal to, this is less than or equal to, or less than, and now I have to apply this right here. If it's greater than or equal to, well, then I have to do that there. It really is that simple, guys. So that really concludes everything for test number 2. And that's the end of this video. Thank you.